button?
No, top right.
That one, okay. Sorry. Thank you very much, Saleit, and the Israeli core team for inviting us here today. Today I'm going to talk about a project that I've been working on for the last 3 years with Richard Maloney, who is at the far right-hand side of the room there, my left. Belinda Mellish, who's 2 seats over. Both Richard and Belinda work for the Department of Conservation in New Zealand, and Hugh Possingham, who you just heard speak. This is what I think is a nice example of a collaboration between scientists and practitioners on working towards a common goal. In this collaboration, we develop science of good decision making and take the priorities that we've developed right to the end and implement it on the ground. So there's 2 components of this process. The first process is to develop the good science and the good priorities, and that's something that I'll be talking about in the first 10 minutes. And the second half of the process is to take these priorities and take them to the practitioners and get them implemented on the ground. And that's what Belinda and Richard have been doing over the last couple of years, and Belinda will talk about that process. In this talk, I'll be focusing on threatened species in New Zealand, but the work that Richard and Belinda and our team at AIDA have been working on also includes priorities for ecosystems. So the conservation problem is that in New Zealand there's greater than 2,000 threatened species, and many of these species are still in decline. Some of these species are so threatened that there's fewer than 150 individuals, and the population's still in decline. So within the next 50 years, we expect those species to be extinct. The other part of this problem is that we don't have all the resources to conserve these species. So we need to make harsh decisions about which species we manage and which species we leave for other organisations to manage. The ecosystem problem is also equally as critical. There's less than 20% of native cover. It's in poor condition, and it doesn't represent what was there originally. So the science that we've been developing is a pretty old science. Like Hugh says, it's about 3,000 years old. But it was developed by the military in the mid-1960s and was first applied to the healthcare and introduced with enthusiasm to clinicians in 1977. Our role as a collaboration between scientists and practitioners has been to adapt this old technique so that it can be applied to biodiversity conservation. And we've demonstrated it on a small case study. And as Belinda will talk about, we've then gone ahead and done it on a whole national system. So the science that we've developed is a project prioritisation protocol. It consists of 9 steps, and I won't go through them now. I'll step you through them in detail in a second. It's quite simple. It can be done in an Excel spreadsheet, and it's a simple process that everyone can understand. So the first step is to state the conservation objectives. The objective that the New Zealand government has come up with is to secure, over a period of 50 years, the greatest number of threatened species of value with the threatened species budget. So by secure, we mean a viable population that is stable and will allow for future recovery. By value, we can have biological, social or economic values, and that's something up to the Department of Conservation in what way they want to value their species. And the threatened species budget in New Zealand is currently about $33 million per year. Now this is the budget that's allocated to conservation of biodiversity, and it doesn't include things like iconic species, ecosystems, recreation or community outreach programs. So it's just the things to conserve the greatest number of species. The next step we need to do is list biodiversity assets. The species listed on the threatened species list in New Zealand include the species that are nationally critical, nationally endangered, nationally vulnerable or in serious decline. So this counts for about 700 species, and they're the species that will be extinct in 50 years if we don't do anything. So I'm going to run through a quick example of 5 species. The way that we weighted species in the original publication was to estimate their taxonomic diversity. So this is the square root of 1 over the number of families in the order, the number of genera in the families, times by the number of species in the genus. And it's just an estimate of how many close relatives a species has. I won't go into detail because I only have 10 minutes to talk. You can put that into the spreadsheet, and then the next step we need to do is list the management projects. For the North Island brown kiwi, we have 7 management projects. The first 4 are management actions that every species requires, so project management, service support, infrastructure and monitoring. The last 3 are things that are unique to the species, and they include predator control, dog control and community relations. So these are things that are very specific in time and space, and we understand the frequency and intensity of these actions. So we can put pretty good estimates of costs on all of these actions. So that's the step 6, is to calculate the costs for each of the actions of the management project. So for the North Island brown kiwi project, it will cost about $12 million over a period of 50 years. We can put that into the spreadsheet, and the next thing we calculate is the benefits of the management project. So the benefits are calculated as the probability of security with the management actions minus the probability of security without management. So it's an estimate of how much the management project will benefit the species over a 50-year period. Step 8 is to estimate the likelihood of success of the management project. And this is a probability that is estimated about if you implement the management project, will it have a positive effect on the species? There's more details about that parameter in the paper, and I can talk to you about it after if you're interested. So now that we have these 4 parameters, we can estimate the project efficiency of each project. And this is the simple science that Hugh and I have both spoken about, and something that you're all familiar with. It's called cost effectiveness analysis. It's the weight of the species times by the benefit of the project times by the probability of success divided by the cost. So for these 5 management projects, you can see that the Maud Island frog is the most cost-efficient management project. It is a very cheap project. It's got a medium level of benefit and a medium weight and a very high probability of success. Compare that with the robust grasshopper, which is a very expensive project. The probability of that project succeeding is very low, and the weighting is very low also. So we did that for 32 species in a case study and estimated the project efficiency of each project and ranked those projects. So you can see the budgets are along the x-axis, the expected number of species secured are along the y-axis. The blue line, which is the unweighted project efficiency, is the most efficient solution. Compare that with the 2 bottom lines, the purple one and the yellow one. These are ranking species by the value or the threat status alone, which are methods that are commonly used throughout the world. So we published this in Conservation Biology in 2009, and we think that the publication has quite a few different values to us. So the first one is that it's I'm rewarded for making publications at my university, so the university system rewards me for making publications, so that's a good thing for me. But the other things that it can do is that the doc staff, the operational and management staff, get some confidence that the science that we've done and the priorities that we've come up with is internationally accepted and as it's peer reviewed. So it brings some level of confidence to the process within Department of Conservation. And the last one is that it's available for future doc staff and other conservation agencies to use and discuss. So the collaboration between Hugh and I and the Department of Conservation does more than just provide a publication and guide priorities within the department. It ensures that the science that I do is relevant, and it gives me the opportunity to learn about institutional and political processes. The immersion within the department can help me define my future research priorities. And one really important thing is I feel like I've become part of a solution that will affect conservation on the ground at the national level, which is something that's really important to me personally. So I'm going to pass over now to Belinda, and she can tell you about the institutional and political side of our collaboration.
Thanks, Liana, and thanks, Salita, and everybody here in Israel for the opportunity to come and learn about conservation in Israel and the issues you face, and the opportunity for us to share our experiences in New Zealand about implementing science into our organisation. So you've just heard from Liana about the technical science solution that the University of Queensland have helped develop to our problem in New Zealand, which is around resource constraints. So, and I think Thomas also referenced this about the importance of including cost in analysis around priorities for places that the conservation problem is far greater than the money we have available. So I'll just talk a little bit about New Zealand and the Department of Conservation, so you get a bit of a context for the kind of agency we are. We're the lead conservation agency for the New Zealand government, and we manage about a third of New Zealand's land area. It's a large area, about twice the size of Israel. And actually something I think I've learned after travelling a little bit in recent years is that a lot of people who haven't been to New Zealand assume it's some sort of pristine island on the other side of the world where everything's in fantastic condition. And that's just not the case. Since humans arrived in New Zealand about 800 years ago, all biodiversity's been in rapid decline. We've got about 25% remaining native land cover. With the introduction of mammals to New Zealand, because New Zealand has no native mammals, we've lost a huge number of species and plants as well. So we've got a big conservation problem. Our organisation, we're a national organisation, like I said. We've got around 1,500 staff spread across the country in about 60 or so different offices. Our agency doesn't deal with just biodiversity. Like many conservation agencies, we also have a mandate for recreation, historic assets and engagement with communities and education, and also tourism and business opportunities on the conservation estate. Our annual budget for biodiversity is around 100 million US, so that's for ecosystems and species, and that includes everything, so that's staff time, salaries and active management on the ground. I'm just now going to talk a little bit about the approaches sort of in the past that our department's taken to planning its conservation priorities, and they haven't been particularly effective. Local managers often make decisions based on their best knowledge. It's not necessarily well informed by science. It's not transparent or consistent nationally either. It's often driven by local capabilities or just the things that people happen to know about in their particular place. But we do have scientists from the department, and over the last 15 to 20 years they have developed many tools around determining priorities for management locations. The problem with those tools is they've been developed, but the social side of embedding them in the organisation and getting them happening on the ground hasn't been achieved. And I think Eric said this morning that conservation is a social activity, and I can't reinforce that enough through our experience here, that you can develop some savvy scientific tools, but unless you address the social, organisational side of getting them in your organisation, you might not get any uptake of them. So our thoughts around how this works is that if you develop a technical scientific solution, so you understand the technical problem, you get an ideal solution, but that technical solution may not allow any resolution of organisational constraints. It may not fit the financial or business planning processes of the organisation, and therefore you may know what the priorities are, but they never get implemented on the ground. And likewise, if you understand your organisation and its culture and how it works and people's attitudes and style, you can get a set of projects on the ground that would suit that, but they may not address the biodiversity priorities that are most important. And so you'll get, in that case, also no uptake of priority work. So the approach that we've taken is to address both of these things in one step. So we've taken a technical solution that Liana talked about, the PPP process, which is very expert driven. And that allows us to address a lot of our organisational constraints because we've chosen a technical solution that suits our organisation. And therefore, we get strong uptake of some priority work. So this is a new approach for our department, and it is working. We've been working on this for the last 3 years, and the first conservation projects will start in action in July this year, which is exciting. So what we're doing is prioritising biodiversity work for the department, That includes 680 threatened species and over 150 ecosystem types. We also have marine ecosystems in our mandate, but we haven't addressed that in this process yet. And of course we want to ensure that we get uptake of that work. And there are sort of 5 key steps that we've undertaken to make sure this happens. The first one, and I'll just flick through these, I think I've got a slide for each. To collaborate with scientists, so you're sure that you're going to be identifying the right things to work on, and that's through the collaboration we have with the University of Queensland. And that gives us, like Liana said, we get trust, and we're sure that we're using good science in our organisation through publications and advice from them. We use Liana and Hugh and other students of Hugh's to help us solve problems. Just recently we had Hugh and a student of his over in New Zealand to solve a very technical problem for us around complementarity for ecosystem and conservation planning. And that's invaluable to us. It's yeah, really useful, and it makes their science relevant too. We use translator roles to ensure that we can communicate the science to our organisation, and that's the kind of role I have. I'm not a scientist and I'm not a local conservation practitioner, but what I can do are all of these things. I understand our organisation and I can explain and reason and engage with people. And I can't emphasise the importance of that kind of role enough in an organisation if you want to take good science and get it working. Like any good conservation project, you need to have a clear goal structure, and we spend a lot of time in our organisation, many conversations, to set our biodiversity goal structure. And just like I said before, we also have a mandate across recreation, historic and other areas. So this goal structure actually sits, there's another sort of 4 slides that would go that way with the rest of our goal structure. We've got one here about conserving a full range of ecosystems, the threatened species example that Liana talked about, and then we've got 3 more here which are around social values, so things that local people might value or our iconic species or ecosystems. You have to achieve ownership of the conservation projects that are priorities with local staff and managers, and to do that we've been using an expert-driven process. And I think, Luigi, you had an interesting slide that made me think about using experts to estimate the number of wolves in a certain place, and that cost more or less nothing compared to the science approach. And I think the other point about that I thought of is also the time factor. There's, I presume, the analysis required to get your confidence intervals around those numbers of mammals is very time consuming. What we're doing here is running workshops, which are multi-day workshops, but we've run around 150 of them over the last 2 years. And we've engaged with about 200 different experts from across New Zealand's universities within our department and Crown Research Institutes. Another large part of this is to get the data that these experts produce, which is the data that Liana was talking about, costs, benefits, feasibility, and take it out to our local staff to get them to validate and check and support it. An example there is initially we modelled cost data for projects based on historical cost data around how much it costs to manage certain things. Our local managers and staff didn't like that. They said, no, you've modelled it, it's not acceptable to us. We want to tell you exactly how much it costs to build a fence around here and how to do pest control. So we spent an extra 3 months visiting all of our 46 different offices with staff, with a laptop, collecting all that data. And interestingly, that data is actually very similar to the model data we used, but the point is we've now got support and buy-in from the organisation to use that data, and they're going to trust the results we come up with. So it's a social process. I guess like any bureaucracy or government agency, we have a lot of business systems and planning processes. We have a financial system, we have a human resources system, we have endless different ways to plan our work, and we put a lot of effort into making changes to those systems so they can pick up and integrate with our priorities. And the outputs that we make are these, we call them a prescription, which is just a description of the project, where it occurs and all the cost and management required. So this is my last slide, and I just want to make a few key points. We've now got 680 threatened species projects described, and we will have 150 ecosystem management projects built by October this year. Like I said earlier, in July we'll have the first ones actually happening on the ground, making a real difference out there. And over the next 3 to 4 years we'll have full transition from the department's current work to this priority work. We're a relatively small team who's run this whole process. There's the University of Queensland people, Richard and myself, and several staff to help us with all the data, but you can run this kind of process in a relatively short time with a few staff and make a huge difference to conservation. So for the same resource that our department currently uses, we're expecting to get about twice the conservation outcomes once we transition to work, and I think for threatened species it is going to be, we'll be securing from extinction twice the number of threatened species in New Zealand that currently are. Thank you.